Today I'm going to demonstrate something called an H.G. Fischer diathermy machine. And this is a spark gap diathermy machine that was in reality a complete working Tesla coil that was sold in the 1920s and 30s. It was made primarily for surgical use, where tissues could be heated and essentially coagulated and then cut away and removed from the body. It was typically used to surgically remove cancer. And specifically it was important because the only other alternative at the time was a scalpel. And by electrically, in a sense, cooking and cutting the tissues away, there was never excessive bleeding because the blood vessels were actually sealed as they were being cut. So it prevented the reinfection of other areas of the body nearby with cancer cells. The machines were used in a rehabilitation sense in the same way diathermy is used today, to heat from the inside out so you could reduce inflammation. And the number one use of it was, though, surgical, basically cutting tissues. If we look around the room, you can see some other machines very similar. They were made from different companies: H.G. Fischer, A.S. Allo, Thompson Plaster, Wappler, McIntosh. There was a lot of competition. But the Fischer Type G diathermy was probably the most popular, and today is amongst collectors because they're a simple machine, yet very elegant in appearance, and the construction is simply superb inside. And I have two machines here side by side so that we can take a look at both the internal and external components. And if we start off to the left, you'll see a variable reactance coil. And this limits the current from 1 to 5 amps from the wall. And it's selected on the outside by this simple rotary switch. Now the current's limited to this beautiful high voltage transformer. And this is something that really, it's important to look at today from a Tesla coiling point of view, because the secondary coils are very carefully wound and insulated. They're in two sections, and they're grounded in the middle, the same as a modern neon sign transformer. Now the difference is there's hardly any protection circuit for this type of transformer, and yet it still works over 80 years later, no problem. I've never heard of any of these transformers actually burning out in a machine despite hours and hours and days of use on many of them. They were designed to operate continuously, so in the hospital field you may have run these machines 4 or 5 hours at a time, continuous. And the fact that they still survive and are still working today is pretty amazing. In this particular model, the secondary was only around 3,500 volts, but at a fairly high current. Now, on the bottom here, you can see where the connections for the spark gap on the other side. It's a 3 series spark gap, and again, very elegant and very simple. There's a 40 pitch micrometer screw and tungsten buttons on the end. And this is the original gap. 1920's, still works absolutely perfect. And the fact that it can operate hours on end really says something about the engineering of it. We have some of the original blueprints to these type of machines here, specifically to this machine also. And we've used some of these inspirations in some of our modern creations here, just specifically because it's 80 years old and it still works beautiful. We also see some mica condensers or capacitors. Again, very elegant and meticulously designed, so that even though the components are exposed, again, it's still working today. To the right we see the actual Tesla coil, and it's a little bit unusual to see the outside because the primary coil is located right here, and it's tapped at the side for a low, a medium, and a high voltage. And that was basically for the medical use of the lower voltage, higher powered currents. This was more for the surgical side of things. And you'll see that half of the primary coil is tapped for the low voltage, all of it's used for the medium voltage. And for the high voltage, there's a little bit extra wire inductively next to it, which increases the voltage even further. Now, on the inside of this is actually the secondary coil, and it's 2 5/8 in diameter, and it's only 90 turns of number 20 gauge cotton enamel coated wire. It's not very many turns of wire, but again, this was very limited in the application, so large sparks weren't the ultimate goal of these machines. And at the top of the case, you can see this is the terminal of the secondary coil. The other end's grounded to this indifferent terminal, and these are the low, medium, and high voltage posts, which are used for surgery. There is also a meter that I've removed for these demonstrations that would register how much current was actually flowing through the patient. In addition, there's a scale where you could set the meter depending on how much current you were using. So if I switch it on here on low power, used to dehydrate the surface of tissues internally, and also for dehydrating the skin. It also draws the light from the primary terminal on the low, medium, and high voltage side. In increasing the current, we're halfway now. See more arc forming in the primary side. The Tesla coil discharge is much hotter. Now, as an example here, I can take an early light bulb, and with one circuit connected to my body, and the other circuit run to the terminal here on the high voltage side, you can actually see the current lighting up the filament. In the early days, this was a way to tell how much current was flowing through the patient if your meter burned out. They would think there was a color scale showing the different degrees of filament lighting up from a kind of a reddish orange to a bright white. Now, in the highest setting, this is rarely used, but you can see we actually get a strong arc. Imagine running through your fingers here, because you get a very bad RF burn. But basically, that's pretty much what electrical surgery was in the early days. Now, there's not much voltage produced by this machine in any of the outputs, but using Tesla's principles, we can connect an extra coil, or tertiary coil, to the machine. And actually get more of the typical spark. From a normal Tesla coil. So you're able to demonstrate simple Tesla principles with these machines without destroying them historically. But this is a common machine. It was used in actually the military for many rehabilitation cases during wartime and so forth. It was used surgically across the country. It was never really considered a quack machine because the books and materials published by Fischer generally kept within the truth of everything. There was never a need for this company to go out on edge and promote things to ridiculous extremes like many of the manufacturers did. So the machine was never banned or part of any sort of conspiracy that you often hear in the alternative medical crowds. It remained in the production throughout the 30s, and in the 40s the only thing that changed with these machines, because of radio, they switched to shortwave, and eventually radio tubes were powering the machines. And so in that case, the concepts pretty much stayed the same. But for surgical use, it's interesting to note that the spark gap type of Tesla coils are still used today. You can use solid state and tube-driven circuits, etc., to power a coil, but you can't exactly get the same degree of coagulation and cutting abilities that you can with a spark gap circuit. And it's just because of the damped oscillations versus undamped oscillations and how physiologically the tissues react to them. If we walk across the room here, in the living room, we can see one of the shortwave versions of this type of technology. This was also made by Fischer in the mid to late 30s. And there's no actual secondary Tesla coil circuit in this. It's just producing the primary side of the circuit. It's a lower voltage than the spark gap machine. And it operates at around 30 megahertz. It's actually a 12-meter machine. And if I open the drawer below, you can get an idea of some of the attachments and tools that were used with these machines. The term diathermy refers to producing heat within the body, so they were typically used to treat infections. They're inductance pads, which were used to heat the body, basically through dielectric losses by using the body as part of a capacitor. And there were also surgical and cutting tools that were used with the machines.